So what's happened in the past few months? Well, I went from having nothing at all to a somewhat usable editor that doesn't crash within 5 minutes. There's still a whole lot of work that needs to be done before I can start building stages, but it's enough for me to make a video on, so here we are. Starting with the engine's interface, I'm using an absolute godsend of a library called GUI. In case you haven't noticed, the perfectly designed, completely original, fully modular interface surrounding me right now, that's what the GUI allows users to build. Being a first-time user, I can say that I was pleasantly surprised at how easy it was to get things going. Documentation for this library is fairly decent, and any problem that I ran into were easily resolved with a quick Google search, usually bringing up a poor soul that suffered before me. Mesh loading. To help me with this, I'm using a library called ASIM. It's short for Asset Importer. Now, the first time I even used this library, I remember I had all sorts of trouble, ranging from linking the libraries to just figuring out how to load a mesh. It was the first time I had to deal with a library being either statically or dynamically linked, and also the first time I had to deal with different runtimes. And even after all that, loading in a mesh proved to be quite an mission as well. Like, did you know loading a mesh with multiple UV maps split that mesh into multiple meshes, and that for some reason I have to reverse the first and last group of the UV map to make things correct, and vertices have to be multiplied by a scale factor, and bones need to be calculated using some weird matrices, and animations. In the end, I copied the code from my past project and called it a day. Good work, Cosmo. Now, in my head, I figured once I had the mesh, I'll just be able to load them up in my engine interface and then click them and have it kind of just pop into existence. Except I was thwarted by the realization that I had nothing to click. So thumbnail generation became a thing, and I had two options. The first was to make an automatic thumbnail generation tool, and the second was to manually make thumbnails and load them when I load the mesh. Obviously, as a person of my talent would do, I did option 1. Build an automatic thumbnail generation tool that automatically generates a thumbnail by taking pictures of the mesh with basic lighting at a fixed angle and distance, and then give up halfway through when I couldn't figure out how to scale meshes to fit within a certain view frustum. Hey, it worked for some things. I gotta give my artist something to do. Texture management was something I made way more difficult than I needed to be. What happened was I set out wanting to make a really efficient texture management system, but due to my misunderstanding of OpenGL concepts, I had to settle for a kind of meh system. What I do first is I read all my textures from a directory and then make a thumbnail of it by resizing it down into a 32 by 32 texture. This thumbnail texture gets plastered onto a texture atlas containing all my textures, and then the path and name gets stored into a custom struct. What I can do with that is give the texture atlas of textures, did that make sense, to GUI and have it render all available textures that I can use for meshes. And when I want to apply a texture to a mesh, then we load the fill size texture from the disk and store that into the mesh's own texture. To get the fill picture, I suppose we need to talk about how I instance objects as well. I have something called an instance group, which holds a single mesh's graphical data and a map of a custom struct I call instance infos. Instant infos have a few things, namely a texture itself, a map of loaded textures, a vector of transforms, and a vector of texture data. Now, the reason my instant group has a map of instant infos is because of the limitation of texture 2D arrays. Texture 2D arrays can be thought of as 2D textures, but stacked on top of each other using the Y coordinate. The limitation is that these layers must all be the same size. To load different sized textures, you need to have a separate 2D array, and so the key to the map is actually the size of the loaded texture. Knowing this, the instance info is pretty straightforward. We have the texture to bind before rendering a batch of meshes, we have a map of loaded textures so we don't keep loading the same texture from disk, and we have the transforms for each instance and texture data for each instance. Notice that it's simply an int, because all this needs to do is tell us what layer on the texture 2D array our texture resides in. So clearly there are some disadvantages to using this approach. For example, that would mean if we had two different meshes that use the same texture, well, we would load the same texture from disk twice. In an ideal world, both meshes should be drawn when a certain texture is bounded, but I just can't be bothered. Resource management is great and all, but how do I actually use my resources? Well, like an investor hearing about crypto for the first time, I jumped onto the hype train that is the Entity Component System, or ECS for short, without understanding a goddamn thing. Right, disclaimer, I'm just gonna tell you what I did. Doesn't necessarily mean how I did it was right. So let's cover entities first. Entities serve as a unique identifier for a collection of components. How I've done this in code is I have a base entity class that contains information that I think all the entities will have. Using this base entity, I can then build, say, a static object entity, which can be made by attaching a mesh component and a collider component. Speaking of components, a component is simply a container that holds information. A component should not hold any logic. It should not hold any logic. I said it should not hold any logic. If you're familiar with Unity, you might know that it also has an easier system. Since Unity was among the bigger, badder boys of game engines, I thought I'd use it as a reference. However, I did become confused when I realized that when I use Unity, I do in fact put logic into the components. So after further research, I found out there are actually many versions of ECS, and Unity was indeed a valid version. Finally, we have our systems. Systems are what manipulate the information stored inside our components. Take my renderer as an example. It loops through all my mesh components, collecting the information before finally rendering every mesh in the scene. Yeah, not much to that one, I think. Where's my notes? Next up is physics, or more specifically, bullet physics. Yeah, I'm pretty sure that's not how that works. We're gonna use it to make cars, eventually. But for now, I threw it in so I could use it for mouse picking, which is the thing that allows me to select my objects. Also, to do stuff like this. Bullet physics is actually what was used in GTA 5 vehicles, so I know it's fully capable of producing vehicles, but hopefully I'll be able to tweak it enough to achieve the kind of driving style I'm after. GTA 5 is a little too grippy for me, but I guess that's the bridge I'll cross when I get there. For now, it's in the project and ready to go. Alright, I think that covers the most important parts. I also added minor things like a gizmo that allows me to move things around, a texture atlas debugger, an inspector that I can move around with, and a grid that likes to mess with your perspective on things. The next thing on my list is to build a level. That means giving the engine the ability to save, and then hopefully, I can make a start on roads. I'll probably spend a fair amount of time on them since they're arguably just as important to a racing game as a vehicle itself. With all the initial setup done, I am hoping to release quicker updates, but who knows. I've probably shot myself in the foot already. Until the next.